Hi there. Today we will be solving problem 1.3. This is from the chapter of vector algebra, and the textbook is Introduction to Electrodynamics, and the author is David J. Griffiths. This is a standard electromagnetics text. The problem at hand is to actually find the angle between the body diagonals of a cube. Now, in the picture here, I have shown the cube and also I have marked the axes. Now, let's go ahead and name these axes. Let us call this X, let us call this Y, and let us call this Z. Once we mark these axes, the next job would be to start drawing the body diagonals. Remember, solving any problem in electromagnetics comes down to writing very good diagrams and also using symmetric arguments all the time. So, body diagonals could be chosen in any which way. I will choose these two body diagonals for the sake of this problem. One is as shown here, the second one would be as shown here. Now, let's go ahead and name these points as A, B, C, and D. Now, these are the two body diagonals. There could be other examples of body diagonals too, but I've chosen the one which makes my problem simpler. I will go ahead and explain why it becomes simpler when I choose these. Now, all that I have to do is find the angle between these body diagonals, which means it could be either this angle or this angle. Let's call each of them either theta and phi. So we have to find the angle theta or the angle phi. We don't know what it is and we have to find both of them just to make sure there is no ambiguity in the answers. So how do we go about doing that? Even before we go ahead any further, we'll spend a little more time on the diagram itself, so that once we mark out every possible detail on the diagram, solving the problem becomes a very easy task. Let us go ahead and mark the coordinates of each of these points. Also, A also happens to be at the origin, so we will name the origin there as O. So this is the origin. A and O coincide. So the coordinates of each of these points would be in the Cartesian coordinates 0, 0, 0 for A because it's at the origin. B is in the three-dimensional space. Now, if we assume each side of this cube is of the side P, which means all the sides have the same dimension of P, then B would be P units in the X direction, P units in the Y direction, and P units in the Z direction. So that would make it P, P, P for B. And for C, you see that C is along the y-axis, which means we will just have a point which is 0, P, 0. And for D, it would be the point is lying here in the xz plane, so we will just have x and z coordinates, which is again P, 0, P. Now, when I say the coordinates, it means it's x, y, and z. This is the same for all the 4 points. So once we have identified these 4 points, all that we need to do right now is to actually find the angle between vector AB and vector CD. So if we find the angle between these two vectors, that would solve our problem. So how do we go about doing that? If we observe carefully, we see that these two are vectors, so the angle between two vectors can be found out through the dot product. We know that the dot product of two vectors A, B and CD, so this is a vector on its own and this is a vector on its own, is equals to mod of AB mod of CD into cos of the angle between the two vectors. Now, we know that the scalar dot product is results in a scalar, and this is the mod value, and this is the angle between the two vectors. So from this we find that cos theta is equals to AB dot CD divided by mod AB mod CD. So once we know this, we know that theta is equals to cos inverse of AB dot CD mod AB mod CD. Now this would be theta. So all that we have to do right now is find AB and CD. Let's go ahead and find AB. From the definition of vectors, a vector AB would then be defined as the position vector of B minus position vector of A, where OB and OA are the position vectors of the point B and point A. So if you look at it here, so OB would be along this direction and OA would be the point itself from O to A. So as a consequence, we will have OB to be, because OB is along AB, it means OB will be Px plus Py plus Pz. This is OB. And OA, because O and A are coinciding, we will have the point to be 0x, 0y and 0z. This follows from the result that origin has the coordinates 0, 0, 0. As a consequence, A also has the same coordinates, and hence the position vector is 0x plus 0y plus 0z. That will give us AB to be equal to P minus 0x plus P minus 0y and P minus 0z, where these are unit vectors in the axis directions. So that will give us Px plus Py plus Pz. That's AB for you. Let's name it as 1. Similarly, we will go ahead and find CD. CD would then be defined similarly as OD minus OC. Again, position vectors of D and C are used to find CD. So that would mean OD would be along this direction, which is basically the coordinates of the point D, which is, we know that D has a coordinates of P0P, so that would make it Px plus 0y and Pz minus OC. OC is along this direction, so which is just a y coordinate, so which means we just have 0x plus Py plus 0z. Now this is for OD and this is for OC. That would make this problem P minus 0x, 0 minus Py and P minus 0z equals to, CD would then be equal to Px minus Py plus Pz. This, let us call this 2. Now, once we know AB and CD, let us write it down. AB is equals to Px plus Py plus Pz, and CD equals to Px minus Py plus Pz. So the mod values of AB would then be square root of the squares of x component added with squares of y component added with squares of z component. That is going to be 3p square. And similarly for CD, the mod value would be squares of x component plus squares of y component plus squares of z component. Again, that would be 3p square. What is AB dot CD, that would be Px plus Py plus Pz dot with Px minus Py plus Pz. From the vector algebra, which is very primitive, we know that x dot x is equals to 1 and x dot y is equals to 0 and x dot z is equals to 0, and it applies similarly to y dot y is equals to z dot z is equals to 1, y dot z is equals to y dot x is equals to z dot x is equals to z dot y is equals to 0. So these relations follow from primitive vector algebra, which gives us, in the above case, p dot with p is p square, and p again dotted with minus p gives us minus p square, and finally we have p multiplied with p gives us p square. So on a whole we have p square minus p square plus p square. We can cancel out one set of them. So AB dot CD is equals to p square. Once we know vector AB dot vector CD, we can go ahead and find the mod AB multiplied with mod CD, that is equals to root 3p square multiplied with root 3p square, that will give us 3p square. So yeah, this result is obtained from these values earlier. So mod AB into mod CD will be 3p square. So once we know all of this, we can go ahead and simplify the problem. So we know theta is equals to cos inverse of vector AB dot vector CD divided by mod AB multiplied with mod CD. Now once we know the formula, we can substitute these above values. Cos inverse of the numerator would be p square and the denominator would be 3p square. We can cancel the p squares, which will leave us with cos inverse of 1 by 3. So theta is equals to cos inverse of 1 by 3. Then automatically phi would be equal to 180 degree minus theta. So that would make it 180 degree minus cos inverse of 1 by 3. Now we can go ahead and calculate this. So cos inverse of 1 by 3 is given to be equal to 70.528 degrees. So as a consequence, so theta is equals to cos inverse of 1 by 3 is equals to 70.53 degrees, and as a consequence we would then have to find phi, which is equals to 180 degrees minus theta, that is equals to 180 minus 70.53, that is equals to roughly about 109.47 degrees. So this gives us the value of both theta and phi, and it solves the problem to our satisfaction. Thank you. Please subscribe to this channel for more problems and more videos. Thank you.